Hi everybody, good afternoon. Can you hear me well? Normally I have the opposite problem, I'm too loud, but hopefully for this big room will work. Thank you so much for taking the time. I want to start first with trying to understand how many of us in this room trust AI with the most important decisions in our life. Would you trust AI to decide whether your children go to university? Would you trust AI to decide whether you get your dream house? Would you trust AI, with anything really important, whether it's for your work or for your life? So let's have hands up, people that would blindly trust the AI with, life or death decisions, or, with things that will change your life. Okay, so 0 people in the audience, maybe half. There's an undecided person there. So about half a person in about 100 and so people trust the AI. That actually kind of checks out. About 87% of all projects in AI around decision making just completely fail before they see the light of day. Out of the 13% that are left over, only 22% actually are used for sort of peripheral decision making. So that's about 2.7%, which kind of checks out with the number we got today in this room, right? And I want to share with you today kind of why that is. So let's start with an example of shark attacks and ice cream sales. Imagine you're so bored, you go to the beach and you just count the number of people that buy ice cream, and occasionally, you're maybe in Sydney or somewhere, occasionally someone gets eaten by a shark, so you just note that down and you have nice Excel spreadsheet with this data: ice cream sales, shark attacks. And then you're like, oh great, I'm gonna do some statistics because I'm so bored, right? You're at the beach, you have nothing to do. So you run a regression analysis and you're amazed. You're like, oh my god, I can use shark attacks to predict ice cream sales. And you rush to the local factory to sell them this model. Be like, guys, I can help you decide how many ice creams you should make. Just look at the shark attacks. And this is what today's machine learning based on correlations usually learn. They learn these spurious patterns that happen to correlate, but they don't really have any cause-effect relationships. Us in the room here, we kind of get it. We're like, yeah, but it's just a spurious correlation. I've seen many of them before. It's the sunny weather that attracts people to the beach to eat ice cream and get eaten by sharks. And so we've actually seen this problem in the real world. And you may not have been able to get the common denominator between all of these high, spectacular failures of AI. But actually, the common denominator of all of these things is spurious correlations. Take Apple Card. Someone was really bored as well at the beach probably, and was just changing their gender in the app, and they figured out that if they change their gender from a female to male, they get more credit on the Apple Card. Wonderful. There was IBM that was using correlation-based AI to detect cancer and suggest treatment, and they realized that actually if you do this, you end up with a 4 billion loss in a business unit. So if you just when you go back home tonight and you look at all of the high caliber failures of AI, just think about this common denominator of correlations, spurious correlations in the data that the AI has picked up from the past, and now it's replaying into the real world. So today's talk is about changing this. We want to come back here in a year or two, and we would like more than half of the room to raise their hand and say, yes, I do trust AI now, because my AI is causal. I can apply causal reasoning and I can guarantee outcomes beyond historical data. It's a shame, really, that we have this huge potential of AI in business, in healthcare, in how we run society, yet we can't really realize that dream of AI. AI does the work, we're at the beach, eating ice cream, because we don't trust it. And so today's talk is about how can we change this, and how can we be sitting here in a year's time and have a much larger number of people raising their hand and saying, yeah, I do trust the AI now because it's causal AI. It guarantees outcomes. So this is just kind of the chronology of how we were making decisions in business, in society, and so on. We started off with gut feel. Yeah, that feels about right. Let's do it. There's still a lot of businesses and a lot of politicians that apply that method from the 19th century. We then realized that actually if we collect data and we apply correlation analysis and regressions, that we can get a little bit more insight. So we're doing this for about 100 years. And then big data came, and it was wonderful because we could actually throw insurmountable amount of data into a black box, and something came out. And we built loads of cool products with, something comes out from the black box. They were very, very fun, and they were great for board games and things like that. But a lot of those high failures that we saw, these high caliber failures we saw in the beginning. Well, those are all because of this, statistics on steroids, essentially. So today I would like to convince you that the future is about causal reasoning and teaching machines to understand the world very much like we humans do, through cause and effect. And we don't want to be fooled by these spurious shark attacks, ice cream type of spurious correlations in the models, in the AI decision systems that really, really matter for our society, for healthcare, for businesses. So today I'll talk about causal AI, which is the future of how we're going to be making decisions everywhere. And I want to cover three things today. I don't know why they're all ones, but yeah, 1, 2, 3. So there's probably a correlation AI there. I didn't figure it out, but I want to talk to you today about how we can go away from predictions. Predictions are kind of all AI can do today. I learned some correlations, and I just hope that the world stays the same, and I'll just predict stuff. But I want to convince you today that that's not enough to make really good decisions. I also want to show you a new way that machines and humans can partner for the first time through the common language of causality. I want to also illustrate and to you guys that we can have transparent and fair AI. One, that when you change the gender in your app, you still get the same credit, same credit card, same amount of credit card limit. So that's what we're going to talk about today. So the first step is about, why do we need causality for decision making, right? Remember how, in our shark attack and ice cream, we only had 2 variables. Really, that's what correlations are by definition. We take 2 variables, we regress them, we figure out one number, right? Which has no direction. We don't know if A causes B or B causes A. We don't know if there's a variable C that affects both of them, like hot weather affecting both ice creams and shark attacks. So I want to convince you that in order to make real decisions that really matter for your business, for your life, for our society, we need to look at the world through the language of causal diagrams, which are not one-to-one relationships. Instead, they show you how the entire system works through cause and effect. You'll notice that there is direction of causality here. So we know that sun can cause the temperature to go up, not the other way around. We also know that it's the temperature that actually gets people to go to the beach and eat ice creams and get attacked by sharks. But if we're trying to figure out what causes skin cancer, there will be probably high degree of correlation between ice cream sales and skin cancer. But we should not use that in order to figure that out, in order to figure out the causes of skin cancer. In fact, remember how I told you for the last 100 years we were fooled by spurious correlations? Well, the tobacco industry used those spurious correlations to convince us for 30, 40 years that smoking is not so bad for your health, because they could get away with it. They could find spurious correlations. I think it's time for making better decisions by looking at the more holistic picture. I want to introduce this idea of recourse. Essentially, it's a causality term, but it's about how can we go from predicting something which is not so useful to a actionable decision. What can we do about it? Imagine you are a marketing person and you're trying to, or an HR person, and you're trying to figure out how to prevent Andre from churning in the next 3 months. You really care about Andre, and you really want to keep him. So just predicting that Andre is going to churn is kind of useless, right? And of course, this problem exacerbates at large scale when you have cohorts and lots of people. The real question is, what is the recourse? How can I prevent Andre from churning, and what constraints do I have, and what investments do I have to make in order to do that? So imagine now, rather than being so focused on predicting stuff like the entire machine learning community, imagine now focusing on, here's what I can do about it. I can provide a discount, and I have a budget of $5 to do it. Dear machine, could you please help me understand what can I do in order to prevent Andre from churning, right? And this is what causality opens up for the first time. It allows you to change the outcome, not just predict it. And this is a fundamental shift in how we think about AI. So in this case, the machine tells us that if Andre was provided with a $4 discount, he will not churn. Wonderful outcome. Now I want to tell you a little bit about the future of human-machine partnership. This is a really, really big deal, because so far, when we are building decision systems, we have data scientists and engineers in the basement, and we have the business people up there, on the floor, and there's a broken communication between the two. So the guys in the basement are building a lot of code, they're doing a lot of smart things, utilizing their PhDs. They come to the business and they're like, look, I spent 3 years on this. What do you think? Oh, it makes no sense. Doesn't have the business constraints, has loads of spurious correlations. This is not how the world works today. Go back. Okay, we go back to the basement, we spend another 3 years, and we basically never end up in a world where we can bridge the gap. Now imagine a different world where you don't start by spending 3 years in the lab, in the basement, modeling stuff. Instead, the first thing you do, you say, here's a causal diagram. We can infer this from the data automatically, day one. Now, let's get the business to, through a beautiful user experience, provide input about how the world works, what is really causal, did the machine get it right, can I bring domain knowledge around kind of how my business works, what are my constraints, I can provide $5 discount, not 20. And imagine now we're going from nothing to a causal diagram that everybody agrees on in a day. Game changing, right? Not 3 years in the lab coding stuff, showing it to the business. Day one, we take data, infer causality automatically, the business comes in, and now we have a causal diagram that we all love. The business agrees with it, the data scientists love it, and now they can build a causal model by tomorrow. So we go from 3 years to 2 days, and everybody's happy, right? And I'm not showing you kind of a lot of details here, but would love to show you if we have the opportunity to grab a coffee later. So remember how Apple had this problem of changing your gender meant you could get more credit on your credit card? Well, that's, it's not great. And the reason you get into that is, here's my example. The reason you get into that is because you learned this spurious correlation between gender and how much loan you can give to someone. If Apple had a causal diagram, what they would have learned is that yes, gender and credit limits are correlated. We've had a lot of injustice in the past, but we don't want to repeat them. The real causal driver is income, right? It's completely fair for someone's income to decide how much credit they get from the bank, right? So that's good. Everybody's happy with that. But we cannot use gender in order to decide how much credit you get. And you can only figure this out if you have a causal diagram. But actually, just before you get too excited, it's not about the past, right? Correlations are great at the past. We're talking about unseen data here. We're talking about examples in which we've never seen in the past, right? We want this model to guarantee fairness even if we've never seen the data. And causal diagrams and causal models do that. They guarantee fairness on any data, no matter how far it is from what we've observed in the past. And that's a big deal, right? Now we can trust it. Now we know that no matter what happens, no matter how the world changes, this thing is going to work and is going to provide fair outcomes for us in society. Now, hopefully by now you're like, okay, wonderful, causal AI is the future, great. This guy here is telling me all about this causal AI. Should I really trust him? Well, don't just take my word for it. Look at the evidence. All the big tech is investing heavily in causality. All of the new, all of the new research teams are doing causality. So they're actually forming teams specifically for this. If you go to a top machine learning conference like NeurIPS, you will see an exponential, like perfectly exponential graph of number of papers for causal AI. Causal AI is now on the hype cycle right next to the metaverse. So it's, in my opinion, it's a bigger deal than the metaverse. But anyway, they're next to each other on the hype cycle. There's actually also a lot of regulation coming in that it will enforce people to use causal modeling and causal decision making in the enterprise. For example, the European Union's legislation explicitly states causal models as the only way to get approved, approval for high risk use cases, which normally involves a human being. So if you're making a decision that impacts human beings, you better have a causal model, otherwise you're going to get into a lot of legal trouble. There's similar legislation in Singapore, Canada, and the UK as well. But the EU explicitly mentions causal models, and EU is always a little bit ahead with AI regulation with everybody else. And so, because this is really, the science of causal AI is not something you can just figure out overnight, right? It takes a lot of breakthroughs. It requires very large teams. What we've decided to do is to build the world's first causal AI platform so that all of you could benefit from it today. Not in 3 years' time when Google figures it out, but today. So today, you can use the world's first causal AI platform to bring trust back into artificial intelligence. And we can, for the first time, really benefit from the promise that AI has had. I just want to show you. We just want to show you how this looks like in practice. Imagine this is a bank. You use the causaLens platform to go from raw data to what we call decision apps. Decision apps allow the end user, the business person, whatever they are, to actually consume this beautiful new way of making decisions through a beautiful user experience. So we go from loads of data to a decision app. Here's some examples. In hours. Not in years, in hours. And so if you're a bank, you can imagine a world where you are making all of the most important decisions through this through this platform, where you have broken down everything that matters to the business. You care about staff attrition? Great. We give HR a decision app to figure out not how to predict if we're gonna if people are gonna leave the company, but what we can do about it before they decide to leave the company. They may need to work out, how to stay liquid in stress times, like the times we're going ahead. They may need credit stress testing app. The bank may need ability to figure out credit risk. You remember the Apple Card example? So a credit analyst may need to decide who to give a loan or a mortgage to. They may have an app for that. And so on, right? You can imagine also a high level of abstraction where people that sit higher up in the hierarchy could actually use the input of these decision apps to figure out a better way to run the business more holistically. So this is the future of decision making in the enterprise right here in front of you, and you could have this for your enterprise in a matter of months, not years and decades. And if you do that, you're going to have tremendous benefit. I like to start from the bottom one, which is in a space of 6 weeks, we worked with Mayo Clinic to discover cancer biomarkers. It's something that has taken decades before. In 6 weeks, with the power of Causal AI, we're able to find cancer biomarkers for colorectal cancer in a space of 6 weeks that we now can take forward for regulatory approvals and paves the way to discovery of a novel drug for cancer. We worked with G7 governments during the pandemic to figure out how to execute certain policies in a way that impacts all of us, all of us well-being. For example, the rollout of the vaccine is something that we helped G7 government do with the power of Causal AI. What are the causal drivers of hesitance? What can we do about it? And I'm not going to bore you with these big numbers in the enterprise, but we've applied this technology in supply chains, banking, retail, CPG, everywhere. We've also applied it in Formula One. That's our logo there on the Williams F1. We can optimize, for example, tire strategy. Not just predict what the temperature on the track is going to be, but what is the optimal strategy for the tire so we can win the race. So if you're really excited about Causal AI, and you should be, because it's going to be bigger than the metaverse, this is your opportunity to join the revolution. We're creating a global Causal AI community. We're going to launch the community with the world's first Causal AI conference here in London in November. You're welcome to register and attend. We would love to have you there, and that's how you join the Causal revolution. Thank you so much for listening. Happy to take any questions. We have, I guess, a few minutes, 1 minute, 2 minutes, 5 minutes. Thank you so much.
Sorry. Yeah. How you detect the new relationships of causality? Like you showed the kind of obvious ones, but the ones that AI are showing correlations. How you decide which one are causing which one?
Yeah, absolutely. So I think if it's a dynamic system where things can change over time, it's important to actually have systems in place that continuously scan for new causal relationships. So, in our platform, we solve this with what we call causal ops, where we continuously monitor decision workflows, and we see if any underlying changes have happened in the world, and we can flag it so that it can get, we take it into consideration and make sure we adapt it so that we're not looking, behind. So, in a static system, causal relationship by definition should not change, but in a dynamic system, yes. And you need to have a system that is mitigating this risk of change and needs to be automated system. Yeah. Thanks. Yeah.
How do you deal with the biases and poor quality data?
Sorry, I couldn't hear that.
How do you deal with the biases and poor quality data?
Biases. So the question was, how do you deal with biases and poor quality data? So, starting from poor quality data, it's a big question. It's a question of definition. What does it mean for data to be poor quality? But ultimately, what you want to do is you want to develop the confidence that the decision workflow that you have in production is delivering, right? And there's many ways to check for this. So I don't think it's a question of, is my data poor? The question is this data sufficient for me to build the decision workflow that I'm trying to build, right? So as you're building your causal models, as you're building the causal decision workflows, you'll figure out if you have gaps in the data. Now, remember we talked about the human and machine coming together? The humans can actually come in and actually fix, they can provide the input where we don't have data. That's the beauty of this new human-machine partnership, is that we may even not have data for a certain relationship, but the human, the domain expert, can come in and actually add that. So we can actually compensate for the lack of data. Same for bias. If the machine couldn't figure it out automatically, that's where we have the humans, the decision makers, to come in and actually fix certain biases if the machine couldn't figure it out algorithmically. So it's about the new human-machine interface, a complete revolution, and getting this at the start of the process, not at the end. Yes, you can have a hybrid. Yeah, exactly. That's we think the future of decision making. Yeah.
One more question.
Okay, one more question.
So I'm not sure I fully understood then how a usual project or collaboration with you works. So you kind of have data we ingested in your platform. You get the first causal relationship from the data itself. Then these are passed to people that have domain knowledge, and they refine them. Is this a?
Yeah, we can grab a coffee. I'll show you how the
Okay.
human-machine interface looks like. I can send you, if you like, a full video. We did a webinar on this topic. It will go like in step by step and show you exactly how it works. So
In here, do you have a booth?
Yes, that's my team there. They will be delighted to show you. Yes.
Okay, let's get a coffee.
Exactly. Well, thank you, everybody. It was a pleasure to have you. Thank you so much.